First of all, I would like to thank the organizers and the University of Navarra for accepting my paper to present here in this insightful symposium. I met Professor Mariano Artigas in Navarra when I was the director of the Department of Anatomy there. And I was very much impressed with his interest in interdisciplinary work and in interdisciplinary projects. This paper I'm going to give you here is a small tribute to him for his ideas and his vision. I have chosen an interdisciplinary approach to neuroscience and free will for two reasons. The first is because neuroscience is right now at the core of all biological research. And the second is because the study of neurobiology of free will shows very clearly one of the paradigmatic paradox of modernity. On the one hand, we all, neuroscientists, at least many neuroscientists, accept that from the biological point of view, we don't have free will at all. But on the other hand, we live in a very, very happily with it in our social and personal environment. So it's a kind of paradoxical view of what's going on. My talk is going to be organized in 4 parts. I'm going to talk about all of them, but very briefly. I don't want to lose time in it, you know. The first one is an introduction of overall rationale of the research I have been doing. But in the introduction, I'm going to try to answer the question, are we free? And to show you some of the challenges to freedom that I right now think that are important to keep in mind. The second part is I'm going to show you some of the experiments that neuroscientists have done. And based on those experiments, the idea of we don't have free will has emerged. At that point, I would like to ask one question, and this is more philosophical. But what freedom are we talking about? And I'm going to end up my talk with some conclusions. So first of all, the introduction. Some philosophical background. I'm not an expert as you all are on philosophy, but I think those 3 fellows here are very, very, very important for how neuroscience is developing right now. René Descartes separated the rexistence and recogitance. We have been talking about that. But most importantly for neuroscience, he focused on consciousness, which is the very core of the neuroscience research right now. Immanuel Kant is very important because freedom is very much, in his view, out of the rational explanation of the human being. It's something that we presuppose, but no, it is not something that we can demonstrate or we can show rationally. And of course, the background of all this is the positivism of Auguste Comte. But the born of neuroscience is very much based on Freud, really, at the beginning of the 20th century. And the main ideas that Freud conveyed to the neuroscience research are here. And I took those ideas from Professor Gray at the American University in Washington, D.C. The first idea is that we do have an unconscious mind. The second one is that we do not necessarily know what drives us to do the things we do, we actually do. And this is very important for medical research right now, especially in psychology. We are formed more than we think in the first 5 years. For language, it's extremely important, this one. So those 3 ideas represent something that we see clearly as a challenge for our freedom. The other point, there's another challenge, is the idea of luck, chance, and the being coincidental. This is very important for the Greek philosophers, because this is a real challenge. I mean, things that happen to us and that we can't control them. What is luck? Luck is very much what the Greek people, the Greek philosopher called TK, whereas chance is automaton. There are differences. Luck is very much like fortune. So you somehow have to work out your life with fortune. So basically, an example of TK, of luck, is this. The real reason dinosaurs became extinct is that they start to smoke. But, sorry, Andrew. But what is chance? This is chance. I mean, it's, you know. But the being coincidental is quite important for our lives. This is the paradigmatic example in the Middle Ages of the being coincidental. So you are going to plant a tree, but at the same time you find a treasure. Both things are not connected whatsoever, but are coincidental. Our lives is very much like this in many respects. Temperament and character is so important, especially temperament. And this is this idea of character and temperament pervading our lives and as a challenge of freedom. It has been in the literature for many times, repeatedly. We call recurring themes of topoi. To do something that you don't want to do. The best example is Medea in Euripides, and you all are familiar with this. Aging and emotion is another important challenge for our freedom. The older we are, the less freedom we have. Because somehow we lose future, in a sense. And emotion is also important for our freedom because we can't control somehow our emotion. So, and our lives are very much interacting with other people through emotion. So at this point, neuroscience comes into play. So we put people in a machine, fMRI machines, and we do paradigms, psychological paradigms, to explore what's going on in the brain. And we see things like this. We explore the experience of regret, and we see, bless you, we see things like this. You see, the orbitofrontal cortex is activated in the experience of regret. So it's very simple. Regret is very much in the prefrontal cortex. So basically everything is in the brain. But you can do things like regret and many other things. And you can see activation in different areas of the brain, which is very much where we are. So basically, we are controlled by the nervous system. But neuroscience has worked the idea of freedom through different experiments on the motor, on the voluntary motor system. And those experiments were carried out by Libet, Hagar, and Sun recently. Libet is very simple. It's, the take-home message of this experiment is that when we do a voluntary motor act, our brain has been activated just many milliseconds before the consciousness of our freedom. So basically, you can see here the activation of the brain before, just before the awareness of the decision to push a red button. Libet demonstrated that this activation is very much in the premotor cortex, an area of the brain. But recently, Sun and co-workers in Germany have demonstrated that the Libet activation was 350 milliseconds, which is a lot in terms of neurophysiology. But these guys in Germany have demonstrated that the activation of the association cortex, I mean almost the whole cortex, 10 seconds, which is just alive really, before the awareness of to push a button. So basically, there is a dissociation here between attention, awareness, and the voluntary action. So after these experiments, can we still speak about the existence of free will? Well, yes, in a sense. I mean, neuroscientists don't believe, many neuroscientists don't believe in freedom anymore. But it's almost impossible to sustain society as it is right now without freedom. So we have to speak about freedom. Yes, we have freedom, but it's a sort of a special freedom. We have the possibility of veto, the activation of our brain that is working, I mean, continuously before our experience of free will. So we can veto here in the chain, in the different step of the organization of the voluntary motor action. Here is the demonstration with fMRI of this veto action. But keeping all this in mind, the problem is how can we explain responsibility? And well, this is how they explain responsibility. I will spare you of reading the whole thing, just briefly note. Culture and education is very much in our brain. Nobody knows how, but that particular things, build some learning signals that eventually there are putting circuits on the brain that activate our behavior. But there are people very, very, very much in the sense of the core of the neuroscience that say we are not free anymore. And freedom is just an illusion. So all these circuits, all these things that I'm explaining you are, things that we talk about, but the actual causal path is the brain, really. We have the experience of freedom, but it's just an experience. But thinking about this, we can still interpret the neurobiology of the voluntary movement as an holistic neuronal network. So let's focus on the motor system and let's try to see a little bit in more depth what's going on in the brain. And basically, the motor system works as follows. We have a plan and program of the movement, and then the execution. And this is very much a network. Our brains are very much a set of networks working together. And at some points, there are nodal points that regulate very much all these networks. And these networks are very much involve the whole brain somehow. So it's interesting because a few years ago, 4 years, a friend of mine in Mexico, José Vargas, which is a very good neurophysiologist, demonstrated in this paper that there are a number of cells called interneurons that are able to put a structure in the brain called striatum, very much in concert, the whole thing. And we did in my lab, we demonstrate in the human brain how these cells are organized. And you see, this is the structure that I am talking about. And you see, all these cells here are interneurons. And these interneurons are all over the place. I mean, all over the structure. So basically, this is very important for this holistic view of how the brain is working. But interestingly enough, recently, people in Japan have demonstrated that this structure is very much linked, all these neurons are linked with projection from the brainstem, dopaminergic projection. When these cells in the brainstem die, Parkinson's disease just arrives. So basically, and Parkinson's disease is in the core of the interpretation of how the motor system works. So basically, the idea of networks working together is a very interesting one to keep in mind in the motor system. But these networks are active all the time. So basically, if you have to keep in mind the correlation between attention, awareness, and freedom and decision, is no longer valid because the networks are always working. So the activation of the brain is always active somehow. So, but the same is true for other processes in the brain. For instance, we are talking about simple things like the voluntary motor action, but let's put things in a more complex way, like, trying to get together vision, visual perception, and motor actions, like in this thing. These people here are playing basketball, and they have to concentrate on the ball and other people. But at one point, somebody, like this, dressed in a kind of fancy costume, passed through them, you see? 70% of the people here didn't realize that somebody was passing through. So attention is not the key point here. I mean, the nervous system is working just in the opposite direction. See, the goal is the most important thing, and you have to keep attention out of the focus. The same is true for this experiment, which is more complicated one. It's the idea of mask. So we have a person, and we put in front of him or her this picture, somebody smiling, for 20 milliseconds. Then we put this for 100 milliseconds. That person will remember only the second one, but we have the ability to know that this picture is still somehow in his or her brain. So basically here, the brain is paying attention of things that in time are more somehow related temporally with him or her. And the same is true for when you have a text like here and you want to focus on the words. You lose the context of the whole text. Why? Because attention is not the key point here. The key point here is focus on a particular goal. That's the point. It's very much like you say something about this morning anyway. And in a more profound or deep way is the division between value and quality. We have this fascinating painting, the Calling of Matthew in Rome. So you can see the value and quality of the painting, but It's a different thing, the feeling state that it produces on you. So attention and the action in the brain is not the same thing. In fact, attention is very much a kind of tool that the nervous system has to focus on the real thing that you are trying to do. So at this point is, what freedom are we talking about? So neuroscientists are saying that we don't have freedom at all. But what do you mean with freedom? That's the question. Freedom, we can say about external freedom and internal freedom. But this is no longer the language of modernity. The language of modernity, the language in neuroscience is positive freedom and negative freedom. We all understand this. And positive freedom is very much self-determination, and negative freedom is to act without any interference. This is very much what we understand right now in modernity with freedom. Although self-determination is something that is around us, but we like the word, it's my impression, but we don't like the concept, because the concept is more complex, you see. It's freedom for or freedom of. We like very much this, freedom of, because we can do whatever you want, but as long as you don't interact with other people, with the freedom of other people. So very much like Plato, we used to say, we are stressing here the I ideal and here the I factual. So what does it mean? Well, for me, one of the best explanation of this is the one that Oakes in '96 quoted from Alistair McIntyre. The I ideal is man as he could be if he realized his essential nature, whereas the I factual, which is very much what modernity and neuroscience understand freedom, is man as he happens to be in the real world. So this is a quote from our paper, one paper we wrote in 2008. Aristotle used to say that the free will corresponds to what is brought forth through our choice, proairesis. This proairesis, which is something very specifically present in the human being, could be defined as the ability to make decisions upon one's life background. Proairesis does not come about because our actions are conscious, you see, but because our actions are able to organize our behavior according to what we think rationally and not only sensibly as good. So I'm going to end up my talk with some conclusion. I have, I think, 5 minutes, right?
Yes.
Right. So the first conclusion is neuroscience right now is very much in a dualistic environment, even though most of neuroscientists are reductionist. But I think we haven't solved the problem of dualism. And this is an old problem, you see. This is René Descartes and Alistair McIntyre. I'm going to just show you two assertions of people in a very, very different way of thinking. One is Alistair McIntyre, who used to say that dualism, as well as relativism and skepticism, is one of those doctrines that have by now been refuted a number of times too often. Nothing is perhaps a sure sign that a doctrine embodies some not to be neglected truth that in the course of the history of philosophy, it should have been refuted again and again. Genuinely refutable doctrines only need to be refused once. Dualism is not the case. But let's go to the other side. John Searle is a philosophy of the mind in Berkeley. I mean, this is very much, he does believe that everything is in the brain. Look at that. Dualism is more pervasive than I had realized. I always thought that it was a peculiar feature of our intellectual tradition. But in any case, I thought Cartesianism is more widespread. It does seem to come very naturally to people to think that there are both a mind and a body. So this is a wonderful lecture on consciousness. You can have it in the web, and it's a wonderful lecture for half an hour. It's probably the best on consciousness I ever had. So basically, dualism is a problem. I would like to try to solve this, saying that we have to deal not with dualism, but with a dual problem. So this is probably I'm thinking on it. So it's not a conclusion right now. But I think the dualism, we have to get rid of it. But we have to keep in mind that we are dealing with a dual problem. The second is, do we understand well enough how neuroimaging illustrates the neurobiology realm of the brain? So basically, what happens here is that in the newspaper on Sundays, I mean the medical section, we have brains, with activation and so on and so forth, and people saying God is in the brain, or the soul is in the brain. And many people think that, God is in the brain, basically. I mean, I'm going to church, no problem, but God is in the brain. And it's kind of paradoxical, really. Anyway, this is a very interesting experiment because it's a twin brothers with the same cognitive paradigm. And you see, in red is the activation of brain areas in one of the brothers, and in blue, the other one. And you see, there are differences, and it's exactly the same cognitive paradigm. So that means that our brains are somehow different with the experience that we are getting on them. And so my proposal here is that we can see neuroimaging just from the other way around. So look at neuroimaging not as usually we look at neuroimaging as a causal action, but look the other way, in an ecological way of looking at neuroimaging. I'm going to talk about ecology of the brain, but I'm not going to link the brain with global warming, which will be the best thing ever. Anyway, but it's an ecological brain because you see self-reflection activate the insula. Anyway, but I'm pretty sure that the insula is moving. I'm pretty sure that somehow the self-reflection is somehow building new biological activity in our brains. And you think, well, it makes sense. I mean, it's another possibility of looking at the brain. I'm almost done, really. This is a study. I would like very much to show this study to Roger Treat, but unfortunately he is not here. But in Oxford, this study has been funded by the Templeton Foundation. They recruit a number of patients, terminal patients with cancer. It's a 25, I believe, terminal patient with cancer, but Christians, and another 25 atheists. And Jack, what happened? You know the experiment.
The same team performed experiments on him.
Oh.
And that's the result. No.
Oh, okay. Okay. So basically, what they show is, and they show a picture of Our Lady, I believe, and a picture of a top model, if I don't, of a woman or something. Yeah. So the idea is that people like Jack, believers, these people present activation in different areas of the brain. So religion, you can say religion is in the brain. No, you can say the other way around. Religion has an kind of impression, so to speak, on the nervous system, which is, I mean, Aristoteles will buy this quite easily. I mean, it's Aristotelian way of looking at neuroimaging. And the third one is life and eccentricity. So this is, I'm very much in this particular, in the third conclusion, close to Plessner and all the German tradition in the recent years. So very much, we have to look at the brain as an ecological structure related with life, really. Life of other people in the first place for us, but also with animals and plants. And I mean, the whole concept of life has been, eradicated in modernity somehow. So basically, the idea of the animal very much in the center of the activity, the, so to speak, brain activity. For the animal, the only thing it has is Umwelt, environment, really. I mean, the whole environment is acting upon it very much. So freedom here is almost impossible. But what happens when the human being appears? You see, the idea of, I mean, there is no lines going to the center because the human being is going eccentric, actually. So, and that's the possibility of relating to the world, Welt. And that is freedom. Thank you very much.
I'm going to ask a quick question just to clarify. When you talk about an ecological view rather than a causal view, are you suggesting that rather than seeing brain activities as the cause of certain behavioral characteristics, seeing, in a sense, starting with the behavioral characteristics or what that implies, and seeing the neural evidence almost as a consequence of that? So sort of turning the cause-effect relationship round, so that you see this as being the neuronal patterns, or correlates, so to speak, being the result of exercises of free will, exercises of decision.
Yeah, yeah. I think when this ecological view of the brain is not mine, really.
Right.
It's a theory of Thomas Fuchs from Germany. But for me, I think it's a very interesting idea because it's a new way of looking at the brain in terms of plasticity. So somehow plasticity is growing from the very beginning in the brain. We thought up until 18 years old or something. But I think that plasticity in the brain, I mean, the ability of the external world to modify the biological activity of the brain, it lasts for all of our life. But it's interesting because in language, for instance, you see, in language, we thought that language is, it was very much important to listen to sounds for, have the ability of speak and communicate. But this is, in my opinion, something that is partially true. Because the most important thing to develop language is that somebody is speaking to you as a different I. So you need the language, you need the sounds, but you need somebody speaking to you from outside. And the more they speak to you, the more you are more yourself. And this is what happens with the mother and the child. I mean, it's always, it's interesting to see the mother speaking to the child, and she's speaking to him or her like an adult. I mean, it comes naturally, but because the child is realizing that it's a new, a different I than her.
So this ecological view, just to clarify it a bit more, this ecological view allows for the intercausality of the material and the immaterial, so that there can be modifications of the brain, at least in principle, which are not causes but are effects of higher non-material causes. Is that what you're suggesting? I mean, in terms of trying to harmonise it with an Aristotelian conception.
Is this the short question?
No, I'm just trying to clarify.
It's the second one. It's the second one.
I won't ask any other questions.
It's hard to give a quick answer, but that's the direction I think we have to work out.
Because that will be what will be required.
That's right. Yeah.
William Carroll.
Well, thank you. The force of the experiments by Libet et alia involved the notion that if there really is such a thing as freedom, then the awareness of the choice would at least be simultaneous with, if not occur before, the change in the brain state. But since the change in the brain state occurs after
before
the conscious awareness, then for sure we must deny
something is going on there.
That's right. So you want to suggest that a different view of how the brain functions attacks that view. There is this is part of my 20 millisecond memory. In March, I read a very compelling essay in a scholarly journal which exists in the Blackfriars Library, and the name of which I have forgotten, as a systematic philosophical refutation of Libet et al., arguing, I don't remember who wrote it, but arguing that there were all sorts of misconceptions in the very argument they put forward on their own terms, which is a particularly good way to refute a position. So, I mean, your argument would say, well, we need to reconceive the brain in such and such a way. The argument in this essay, which as a good scholar I made a photocopy of and didn't completely read, but the force of this essay was to take their own view, their own preconceptions, and show that their arguments don't follow from their own preconception. Are you familiar with what I'm talking about?
Very much. But it's a very complex. I mean, I don't have time anyway to.
Do you know what journal?
Huh?
Do you know what journal?
No, but I'm familiar with the whole discussion of Libet experiment. The Libet experiment has some bias, but Haggard, as I mentioned, I put three names: Libet, Haggard. Haggard replicated the experiment in the late 90s without any bias at all. So basically, the brain is activated really before you are aware of doing voluntary some act, okay? And Sun has demonstrated just a year ago that the activation of the brain is just, long ago before the voluntary awareness of your act. But I think the problem here that we are dealing with is awareness. It's not something, it's to link freedom to awareness, because the brain is working just in the other way around, you see? So the idea of thinking a tennis player, for instance, the more he focuses on the racket, This is a common experience. I mean, I am doing a lot of voluntary acts right now that are out of my awareness, because if I focus on that, I don't focus in answering your questions. So you see, that's the crucial point in this.
Jerry Chandler, I think it's switched off. Switched off.
Somehow.
There we go.
Yes, I would more like to make a comment on the general problems, which was brought up by the question of can you fit this into an Aristotelian causality situation. I have worked on relationships between logic and complex systems in general, networks in general, and it, particularly from the notion of biochemical causality in living systems at all levels of organization. And in my experience, whenever you get into any sort of complex network, Aristotelian causality is not a good setup in which to present the problem. And so I have retreated, in a certain sense, to Stoic logic, which effectively is useful in the sense of antecedent and consequence to describe networks. And this form of logic, which actually is an extension of some of the things that C.S. Peirce has done, allows one to carry on a synthesis, a special form of inductive logic, in which you can get closure and exactness of representation of the network without specifying a particular form of causality. That's my only comment.
Yeah, I agree. I mean, you are going into more of the mind and brain problem, which is a very difficult one. I mean, it's almost impossible. I mean, it's 25 centuries working on it. I mean, it's very difficult. And
life is a challenge.
That's right, you got it. But what I'm focused on is to show how, this is important what I'm going to say. I think neuroscience is a very, very good window to see the paradoxes of modern science. That's the point. That's my point with this, is to show that neuroscience is a very good window to see the paradoxes of modernity. And this is the point. I mean, but mind and brain is a very difficult question. I mean, but still one thing, networks in the brain is, I think there are a lot. But the point, I think the crucial understanding of networks in the brain is to understand the function of the nodal point. You see, so the networks are connected. The problem in the brain is that, for what we know right now, is those networks are bidirectional. You see, so one point, another point, right? That's the problem. That's the problem. Keep going. Yeah, that's the problem.
Well, I